All right, welcome back. Today we're going to talk about chapter 1.4, which is other types of equations. Okay, and the first thing here, we're really only going to deal with a couple here. So the first thing we're looking at are radical equations, and those are anything with a variable under the radical. For example, let's just say we have 2 radical x plus 1 equals 5. Okay, I have a variable there under my radical, which makes this a radical equation. Okay, use substitution. That's not really a type of equation. It's more or less a method used to solving. Okay, so you use substitution. So used to make an unfamiliar equation. I probably spelled that wrong. Equation look familiar. Okay, so you're taking some weird looking equation. You're going to use the letter U. You're going to take some things out, solve it, and then put it back in. And we'll do a couple of those in class. So steps for solving a radical equation. So step number 1, we want to isolate the term with the radical. Step 2 is we will square or raise both sides to a power that matches the root. So if it's a third root, we're going to be the third power, square root square. Step 3, repeat one and 2 until all radicals gone. Okay, so you can do this again if there are more than one radical. Step 4, you will solve. And step 5, check with domain. Maybe before this, you would want to do a domain restriction. So step 0, domain. Okay, we got to restrict that domain. So those are the steps for solving a radical equation. And like I said, we'll do some of those in class. So let's take a quick glance at your questions here. 1, what makes a radical equation? And 2, why would I want to use U substitution? Okay, now the steps for U substitution. Now you can use this on many different types of problems. Okay, I'll show you a very simple one here in just a second. So number 1, identify what you are substituting. Okay, figure out what you want to take out of the equation. Number 2, and this says transform the equation into a quadratic equation. Solve the quadratic equation. Okay, so this one just basically in the book it focuses in on quadratic equations, but we don't have to do quadratic equations with u substitution. So we want to identify what you are substituting. That means put u in. Solve equation with, or solve equation for u. Okay. And then you're going to substitute back in and you're going to solve for the variable. Now, you should have the variable in it. Okay, so let me do a very basic equation here with u substitution. Okay, I'm just going to make something up here. So let's say I have 3x plus 5 minus 2 equals 10. Okay, if I want to use u substitution with this, I'll say u equals, and let's say I want to take this out, x plus 5. Okay, you will have your variable in it. Okay, so you got to take the variable out at least. So then we're going to take u and plug it in for that. So we'll say 3u minus 2 equals 10. Now what happens is it took this difficult equation and it made it much easier. So now we'll solve for u. So let's add 2. So it's 3u equals 12. Divide by 3, divide by 3. U equals 4. Okay, so now we're going to take this right here and plug it back in. So now I have x plus 5 equals 4. Subtract 5 minus 5, x equals minus 1. Okay, now, could I have done this problem without u substitution? Absolutely. Okay, and I hope that you would, but I want to show you the basic idea of what u substitution is and why it might be helpful to use u substitution when I give you a problem that may look like, it might look like this. 2t minus 5t to the half minus 3 equals 0. If I give you something like that, u substitution is going to be much better for that type of problem. So we also have our suggested problems here. 109 is your challenge problem. Again, in this, we're just going to be trying just a bunch of different radical problems and u substitution problems with this. If you have any questions, please let me know. I will link the lesson video, the example video right here. If you want to take a look at that before you come to class, you can do so. As always, this is at THS, Mr. Jones, signing off.